So we here at Aspire believe that A2i is truly a revolutionary way to approach artificial intelligence and machine learning. We've used it already to do things like target over 1 billion digital marketing messages, or figure out how to optimally trade $100 million in the market, but we've never used it on medical imaging data. And we wanted to see how our technology could work if we pointed it at a medical imaging problem. To get a sense for ourselves what a medical imaging problem might look like, we went to something called a Kaggle competition. Now, in particular, we focused on one Kaggle competition that had to do with identifying something called the brachial plexus nerve in someone's neck based on a bunch of radiology images. Now, if you don't know what a brachial plexus is, you're in good company, because we don't know either, right? We have no specific expert knowledge about the medical imaging data, but we're able to turn A2i on it with no assumptions to see what kind of patterns it can find in the imaging data. So we gave ourselves one day to see how well we could do against these 700 teams of data scientists that had spent months and months and months working on this one specific problem by leveraging the power of A2i off the shelf on the medical imaging data. So first, we did a quick Google search for what a brachial plexus is, and we found out that it's here. Like most imaging problems, there are really basically two different parts. The first part is something called feature extraction. So that's identifying the little bits of a picture that are the thing you're looking for. Part two is drawing a tight outline against that brachial plexus once you've found it. So you can think of it as drawing the smallest box you can around the brachial plexus. So in the interest of full disclosure, we didn't really bother much with part two this time around, since, first of all, that's not really the hard part, and second of all, it's something that we can easily focus on later. So it's really hard to know whether the brachial plexus is there many times. I mean, check out these two pictures. When you take into account all the different machine learning image processing techniques and all the different ways you can configure them to attack any given problem, there are literally trillions upon trillions of different algorithms that could be written for this problem. And all the different approaches in the Kaggle competition represent a very small set of those trillions. They might employ things that you've heard of, like deep neural networks or Bayesian classifiers or support vector machines, and incorporate things like brightness gradients and contrast filters and on and on and on. And we're actually going to use some of those today. So using artificial intelligence and advanced math, A2i can generate potentially millions of unique algorithms and models and find good variants very, very quickly. So normally you can take several man-years of development and throw literally tens of thousands of CPUs at this kind of problem. And that's exactly what Google does. In our case, we're only going to give 3 guys one day, and they'll use only 3 computers with 8 cores each. So that's 24 to Google's tens of thousands. The Google guys basically build their deep neural nets by hand. We're going to do the same here, and our guys are pretty smart too, by the way. We do have multiple MIT degrees working on this team. But we're going to compare the best they can come up with versus how their results were dramatically improved in just a few hours by using A2i. Before we get into the A2i results, let's set a frame of comparison from the Kaggle contest. The contest was open from May 19th to August 19th, and 932 different data scientists in total competed. The top scorer had a score of about 0.73. Now you can think of this as saying that they correctly identified the nerve being in the picture and perfectly outlined about 73% of the time. Now our experiment isn't perfectly apples to apples, so remember we ignored the part about perfectly outlining the nerve, but this should still give you a flavor for how powerful A2i can be and what we accomplished in feature extraction if you assume we could get the outlining right later. So for each A2i adaptive algorithm, Aspire assigns a pair of a developer and a data scientist to specify the high-level steps themselves. So here's the highest scoring algorithm produced by the machine learning expert at Aspire. And here is the score from A2i's version of that same algorithm. So what you can see here is we were literally able to accomplish in a single day with 3 computers what it has traditionally taken scientists months and thousands of computers to accomplish. So this was pretty exciting for us because this means that A2i is capable of drawing industry-leading results in a fraction of the time using a fraction of the resources currently employed by the industry. So all in all, we're incredibly excited about what this means for A2i's ability to revolutionize the field of machine vision, particularly as it applies to medical imaging.